13.5 Making use of the reactivity series. There are 4 things we need to discuss today. 4 uses. Number 1, the termite process. Number 2, making simple cells. Number 3, the sacrificial protection of iron. How to protect iron. And galvanizing also is another way to protect iron. And lastly, a little bit about the reactivity of aluminum. Termite process is to repair rail and tram lines of the railway tracks. Okay, so what is used? Aluminium is used and the iron oxide is used. They will be poured into a container, heat it, and then this hot mixture will be poured into the mold of the rail track, and to repair it. So see, when the mixture is lit, the aluminium will what the iron oxide to molten iron. So iron oxide become iron. It is actually a reduction. So aluminium reduce iron oxide. So the iron runs into the cracks and gaps in the rail and harden. So this is the way to repair. So you look at the equation. Aluminium at the end will become aluminium oxide. We call it as oxidation. Iron oxide will become iron, and we call it as reduction. So the chemical equation will be iron oxide plus aluminium. It will become iron plus aluminium oxide. So this is the process. They fix the mold, they pour the mixture, heat it, already heated, but it is a hot mixture, pour into it, wait for it to be hardened. Okay, pour into it. So that's it. Second usage, making simple cells. You can see the 5 metals on the left hand side. From the bottom to the top, more and more reactive. Magnesium is the most reactive metal. We put 2 metal strip into a solution, ionic solution. So we put magnesium and copper into it. Okay, magnesium is more reactive, copper is less reactive. Let's see what happens. So magnesium, what will happen to magnesium? Magnesium will dissolve. Since it is more reactive, so it will tend to become ion and become magnesium ion and give up electron. Copper, nothing will happen to copper, but what will happen to the solution? As we know, in this solution we have sodium ion, we have chloride ion from sodium chloride, we have hydrogen ion and hydroxide ion from water. So since magnesium will give out electron, so which one will receive electron? Okay, it is either sodium ion will receive electron or hydrogen ion will receive electron. The answer is hydrogen ion will receive electron because it is less reactive. So less reactive than sodium, so it will receive electron from the copper. Okay, so hydrogen ion receive electron and become hydrogen gas. So you will see bubbles produced at the copper strip. So go to the worksheet. 2 metal strip. B, when the bulb is lit, the current must be flowing. Hydrogen is formed at a copper strip. Magnesium strip is dissolved. Magnesium is more reactive than copper because it has a strong drive to form positive ion. So when it is connected to the copper, it will give up electron and goes into solution. So electron flow along the wire from the magnesium to copper as current, okay? The solution contains sodium chloride. The sodium chloride is from the sodium chloride and hydrogen and hydroxide ion is from water. Like what I mentioned, hydrogen is less reactive than sodium. So hydrogen ion will receive electron from the copper strip and become hydrogen gas. So the difference in reactivity has caused redox action. So F, a simple cell consists of two different metals. So G, electron flow from the more reactive metal and go to the less reactive metal. So the more reactive metal, we call it as negative pole because it gives out electron. The voltage will be lower. So iron is used to make oil rigs, and iron is used to make ship as well. But the problem of iron, as we know, it will be easily. Okay, so what to do is we weld the ship with zinc and magnesium or other things maybe. So how it is welded? The reaction occur, so water, oxygen will rust the iron body, but zinc and magnesium, they are more reactive, so they will be oxidized instead of iron. So these are the pictures. Okay, go to another topic, number 3, the usage number 3, the sacrificial protection of iron. So iron is useful. Iron is can be found everywhere, but we have to protect the iron. So A, iron is used to build out oil rigs and ships, as we know just now. The drawback is it will be rusted. So C, iron can be teamed up. Team up means pair up with what? With a more reactive metal, for example, zinc or magnesium, to prevent rusting. So D, for example, a block of zinc may be welded to the side of the ship. Zinc is more reactive than iron, so zinc will dissolve and give out electron. So the electron will be received by the water and oxygen. Okay, the electron flow to iron, F will pass them on in this reaction. So it will hydroxide will be produced, zinc hydroxide will be produced. So G, that is the overall reaction. Nothing happened to the iron. So H, zinc then is oxidized instead of iron. So this is called sacrificial protection. So but somehow the zinc block that you weld on a sheet will be dissolved, and it will be smaller and smaller. It need to be displaced, replaced. So lastly, galvanizing. Galvanizing also is a way to protect iron. Use zinc to protect iron. So how? So there are two things mentioned here. Number one, car body. How to protect the car body and how to protect the roofing. So B1, in galvanizing, iron or steel is coated with zinc. What happened to the car body? So car body can be so-called laminated with the zinc by using electrolysis. For roofing, we directly immerse the iron into the molten zinc, deep in a bath of molten zinc. So the zinc, the function of the zinc is to keep the air and moisture away. But somehow, even if the zinc coating were damaged, the zinc will still protect the iron. Like what we mentioned just now, sacrificial protection. Electrolysis. Okay, lastly, aluminium is more reactive than iron. Aluminium, number 2, is used to make TV aerial, satellite dishes, ladders without protecting it. Because it reacts with oxygen and form a very thin coat of aluminium oxide. So this thin coat of aluminium oxide will protect itself, okay, to prevent further corrosion. Aerial and the satellite ladder. So go to the worksheet. 2 metal strip B, when the bulb is lit, the bulb is lit, the current must be flowing.